Hello everyone, in this video we'll explore the customer segmentation using k-means clustering. The goal of this project is to segment the customers based on their purchasing behavior, helping businesses and personalize the marketing strategies. We use Python, Pandas, Matplotlib, Seaborn for visualization and skitlearn for implementing k-means clustering. Here these dataset documents all transactions between 2010 and 2011. Our primary objective is to amplify the effective efficiency of marketing strategies and boost the sales through customer segmentation. These customer segmentation dataset by creating a new features that will facilitate the segmentation of customers into the distinct groups using the k-means clustering algorithm. This segmentation will allow us to understand the distinct profiles and proficiencies. First of all, by setting an initialization, first of all I'll import all the necessary libraries that we will use throughout the project. These generally include the libraries for data manipulation, data visualization and other based on the specific needs of the project. Next, I'll load the dataset into the Pandas data frame, which will facilitate the user manipulation and analysis. And then afterward, I'm going to gain a thorough understanding of a dataset before proceeding to the data cleaning and transformation stages. And coming to the data overview, first I'll perform a preliminary analysis to understand the structures and the types of data columns. The dataset contains 8 columns. Here is a brief overview of each column: invoice, stock code, description, quantity, invoice data, unit price, customer ID, country. Now I am going to generate a summary statistics to gain initial insights into the data distribution. And this step encompasses and comprehensive cleaning and transforming a process to define the dataset. It includes addressing missing values, eliminating duplicate entries, correcting the anomalies and a product code and description and other necessary adjustment to prepare the data for in-depth analysis and modeling. Initially, I'll determine the percentage of the missing value present in each column, followed by selecting the most effective strategy to address them. Customer ID percentage 34.52% and the description is 0.31%. Missing values. Coming to handling duplicates, next I'm going to recognize the duplicates rows in the dataset. And then going to cancel the transactions. To refine our understanding of a customer behavior and preferences, we need to take into account and the transactions that were cancelled. Initially, we'll identify these transactions by filtering the rows where the invoice starts with C. Subsequently, we'll analyze these rows to understand the common characteristics and or patterns. Strategies: correcting stock code and analysis. First of all, let's find the number of unique stock codes and to plot the top 10 most frequent stock codes along with their percentage frequency. This is top 10 most frequency stock codes. To develop a deeper into identify these anomalies, let's explore the frequency of the number of numeric characters in the stock codes, which can provide insights into the nature of these unusual entries. Coming to the Let's calculate the percentage of the record with these anomalous stock codes. And then the strategies will be a filter out and remove the rows with these anomalous stock codes from the dataset before proceeding with further analysis and model development. Cleaning description, and this unit price description contains the lowercase characters, and removing the rows where the description contains a server related information, next day carriage or high resolution images as these. Treating zero unit prices. In this step, first I'm going to take a look at the statistical description of the unit price column, and coming to the outlier treatment. In k-means clustering, the algorithm is sensitive to both the scale of the data and presence of outliers, as they can significantly influence the position of centroids, potentially leading to incorrect cluster again assignments. However, considering the context of this project, where the final goal is to understand the customer's behavior and preferences through k-means clustering, it would be more prudent to address the issues of the outliers after the feature engineering phase, where we create a customer-centric dataset. At this stage, the data is transactional, and removing the outliers might eliminate valuable information that could play a crucial role in segmenting clustering customers later on. Therefore, we'll postpone the outlier treatment and proceed to the next stage for now. In order to create a comprehensive customer-centric dataset for clustering and recommendation, the following features can be engineered from the available data. RFM features, recency, frequency, monetary. These matrices helps in understanding the customer buying behavior and preferences, which is pivotal, and personalizing marketing strategies and creating a recommendation system. Coming to frequency, in this step I am going to create two features that quantify the frequency of a customer engagement with a retailer, and then going to the monetary. In this step I am going to create two features that represent the monetary aspects of a customer's transaction: total spend, average transaction values, and all. Going to product diversity and product behavior. In this step we are going to understand the diversity in the product purchasing behavior of a customer. Understanding the product diversity can help in crafting personalized marketing strategies and product recommendation. Here I am going to define unfollowing features: unique product purchased, and behavioral features. Or in this step we are aimed to understand and capture the shopping patterns and behavior of the customers. These features will give you insight into the customer's preferences regarding when they look to shop where, which can be a crucial information for personalizing their shopping experiences. Here are the features I am planned to introduce. And then going to geographic features. In this step we'll introduce the geographic features. Location customer, understand the geographic distribution of customers. It is pivotal for several reasons. And then going to cancelled insights. And this step I am develop deeper into the cancellation patterns of a customer to gain insights that can enhance our customer segmentation model. These features I am planning to introduce are And then coming to the seasonality trends, in this step I'll develop into the seasonality and the trends in a customer purchasing behavior, which can offer the invaluable insights for tailoring marketing strategies and enhancing customer satisfaction. Here are the features I looking to introduce: monthly spending means and spending trend like this. We have created a dataset that focused on our customers using a variety of new features that give us a deeper understanding of their buying patterns and preferences. Let's review the description of the column in the newly created customer dataset data frame. We have done a great job. So we have created the dataset that focuses on our customer using a variety of new features that gives us a deeper understanding of the buying patterns and preferences. Now that our dataset is ready, we can move on to the next step of our project. This includes looking at our data more closely to find any patterns or trends, making sure our data is in the best shape by checking for the handling any outliers and preparing our data for the clustering process. All of these steps will help us build a strong foundation for creating our customer segments and eventually a personalized recommendation system. Coming to the outlier detection and the treatment. In this session, I'll identify and handle outliers in our dataset. Outliers are data points that are significantly different from the majority of other points in the dataset. These points can potentially skew the results of our analysis, especially in k-means clustering, where they can significantly influence the positions of the cluster centroids. Therefore, it is essential to identify and treat these outliers appropriately to achieve more accurate and meaningful clustering results. Let's proceed with the approach. And after applying the isolation forest algorithm, we have identified the outlier and marked them in a new column named each outlier. We have also calculated the outlier score, which represent the anomaly score of each record. Now let's visualize the distribution of these scores and the number of inliers and outliers detected by the model. This is a outlier score 94.92% and 5.08% is outlier. And then we have successfully separated the outlier for the further analysis and cleaned our main dataset by removing these outliers. This cleaning dataset is now ready for the next step in our customer segmentation project, which includes scaling the features and applying the cluster algorithms to identify the distinct customer results. Correlation analysis. Before we proceed to k-means clustering, it's essential to check the correlation between the features in our dataset. The presence of the multicollinearity, where the features are highly correlated, can potentially affect the clustering process by not allowing the model to learn the actual underlying patterns in the data, as the features do not provide the unique information. This could lead to clusters that are not well separated and meaningful. If we identify the multicollinearity, we can utilize the dimensionality reduction technique like PCA. This technique helps in neutralizing the effect of multicollinearity by transforming the correlated features into a new set of uncorrelated variables, preserving most of the original data variances. The step not only enhances the quality of the clusters performant but also makes the clustering process more computationally efficient. This is the output for correlation matrix. For the future scaling, before moving to the next step, considering the impact of multicollinearity on a k-means clustering, it might be beneficial to treat this multicollinearity possibly through the dimensionality reduction technique such as PCA to create a set of uncorrelated variables. This will help in achieving more stable clusters during the k-means clustering process. Feature scaling for k-means clustering, and then going to dimensionality reduction step. We need a dimensional reduction for multicollinearity detecting and better clustering with k-means, noise reduction, enhanced visualization, improving a computational efficiency. And in this step, we are considering the application of the dimensionality reduction technique to simplify our data while retaining the essential information among the various methods such as kernel, PCA, ICA, and UMAP. I am starting the PCA. Here is why PCA is excellent starting point, because it works well in capturing the linear relationships in the data, which in a particular relevant gives the multicollinearity we identified in our dataset. It allows us to reduce the number of features in our dataset while still retaining a significant amount of the information, thus making our clusters analysis potentially more accurate and interpretable. And then going to methodologies. This is the code for cumulative variance was number of components. For this plot and the cumulative explain the variance values indicate how much of the total variance in the dataset is captured by each principal component, as well as the cumulative variance explained by the first n components. Here we can observe that the first component explains approximately 28% of the variance. The first component from the plot we can see the increase in the cumulative variance starts to slow down after the sixth component, captured about 81% of the total variance. Now let's extract the coefficient corresponding to each principal components to better understanding the transformation performance by PCA. And going to k-means clustering is an unsupervised machine learning algorithm that clusters data into a specified number of groups by minimizing within cluster sum of squares, also known as inertia. The algorithm is iteratively assigns each data points to the nearest centroid, then updates the centroid by calculating the mean of all assigned points. The process repeats until the convergence or a stopping criterion is reached. And then determine the optimal number of clusters. To ascertain the optimal number of clusters for segmenting customers, I'll explore two renowned methods, elbow method and the Silhouette method. And these elbow method is a technique for identifying the ideal number of clusters in a dataset. It involves iterating through the data, generating a clusters for various value of k. The k-means algorithm calculates the sum of squared distance between each data points and its assigned cluster centroids, known as inertia or WCS score. By plotting the inertia score against the k value, we create a graph that typically exhibits an elbow shape, hence the name elbow method. The elbow shape represents the k value, where the reduction in the inertia achieved by increasing the k becomes negligible, indicated the optimal stopping point for the number of clusters. Utilizing the yellow brick library, I will employ the in this session I will employ the yellow brick library to facilitate the implementing of elbow method. Yellow brick, an extension of the scikit-learn API, is renowned for its ability to rapidly generate insightful visualizations in the field of machine learning. And then coming to the Silhouette, from this plot we can see that inertia contains a decrease of significantly up to k equal to 5, indicating that the optimum value of k could be between 3 and 7. This shows the best k within the range. We can employ the Silhouette analysis, clustering the model k-means. In this step I am going to apply the k-means clustering algorithm to segment the customers into different clusters based on their purchasing behavior and other characteristics, using the optimal number of clusters determined the previous step. It's important to note the k-means cluster might again assign a different labels to the clusters in each run. To address this, we have taken an additional step to swap the labels based on the frequency of samples in each clusters, ensuring a consistent label assignment across the different runs. And then Silhouette method is an approach to find the optimal number of clusters in a data set by evaluating the consistency within a clusters and their separation from other clusters. This computes the Silhouette coefficient for each data points. And then coming to the clustering evaluation, for these after determining the optimal number of clusters, which is 3 in our case, using the elbow and Silhouette analysis, I move on the evaluation step to assess the quality of the clusters formed. This step is essential to validate the effectiveness of the clustering and ensure that the clusters are coherent and well separated. The evaluation matrix and the visualization technique I plan to use are outlined below. Visualization top PCs 3D, and in this part I'm going to choose top 3 PCs and use them to create 3D visualization. This will allow us to visualize impact and quality of separation and cohesion of clusters to some extent. And then this is bar plot to visualize the percentage of customers in each cluster, which helps in understanding the clusters of balanced and significant. And then coming to evaluation matrix, to further scrutinize the quality of our clustering, I'll employ the following matrix: Silhouette score, Kalinzik Harbaz score, Davis Bould in score. In this conclusion, the matrix suggests that the clustering is of good quality, which clusters being well defined and fairly separated. However, these might still be a room for further optimization to enhance the cluster separation and definition, potentially by trying out other clustering and dimensionally reduction algorithm. These matrix and values number of observations and Silhouette score and Kalinsk-Hebbe score, Davis-Baldwin score. Thank you.